All right, think about the last time you used an AI tool. Maybe it was to draft a quick email, summarize a massive PDF, or even debug some frustrating code. Feels a bit like magic, right? But beneath that super sleek interface, there is this massive, invisible, mechanical layer running the whole show, the dataset. Today, we are popping the hood. We're going to dive right into the actual architecture of that data because there is a fascinating evolution happening right now in how we build intelligent systems. We are looking at the absolute bedrock of how machines decide what's true, and more importantly, how we can architect a way, way better system of trust. So when you look closely at the foundation of these systems, you hit this really fascinating, kind of scary concept. We usually just assume, hey, it's processing millions of data points, so it's got to be flawless, right? Like sheer volume equals perfection. But listen to this quote, it totally flips that idea on its head. One of the quiet flaws in modern datasets is that they often flatten trust. Wow, just let that sink in for a second. Trust is being flattened. It's such a provocative idea. It completely challenges this basic assumption we all have about the perfection of the data feeding our most critical tech. Part 1. The quiet data flaw. To really get what this vulnerability is all about, we need to look at exactly what happens the second raw information hits the data pipeline. This is the flattening effect in action. Look at this. Every annotation enters the same structure. Every signal appears equally credible. Every single contribution looks totally interchangeable. It's practically a factory assembly line. The pipeline doesn't discriminate. It doesn't pause to appreciate nuance. It just swallows this vast ocean of input and stamps every single piece with the exact same generic authority. One, next, one, next. It's totally sterile, and it treats every data point absolutely identically, no matter where it actually came from.
Part 2, the reality of knowledge. Let's break out of that sterile pipeline for a minute because, well, the messy reality of human knowledge definitely does not work like a factory. Out here in the real world, some inputs come from absolute pros, people with decades of proven precision. We rely on experts for a reason, right? But then, on the flip side, well, we've all been on the internet. We know the massive difference between a top-tier expert and, say, a troll aggressively typing nonsense at 2 a.m. just for kicks, or someone intentionally spreading misinformation. Human knowledge is wildly variable, but standard datasets, they treat the renowned expert and the late-night internet troll with the exact same blind acceptance. It's literally absurd when you think about it. And here is the real danger. Erasing those differences means you are actively erasing human judgment. When these systems just ignore context, when they don't care if an input is from a genius, a beginner trying to learn, or someone being intentionally careless, they strip away the very thing that makes data valuable. You aren't just losing a little nuance, you're throwing out human judgment entirely. For AI systems that are literally designed to mimic human reasoning, losing that fundamental layer is a massive, massive vulnerability. Which brings us to part 3, structuring data credibility. If the flaw is flattened trust, then the fix is a complete paradigm shift in how we build data from the ground up. This is where the code-data approach comes in, and it's a real game changer. They look at data through a completely different lens. Instead of just shrugging and accepting that confidence is invisible, they introduce something called structural credibility. What this actually means in practice is that credibility isn't just some afterthought or a separate metric tacked on at the end. It's baked right into the dataset's architecture. Trust is woven into the very fabric of the data itself. It's kind of like giving the dataset a sense of self-awareness. So how does that actually work? It's built on 4 pillars of structured trust. First up, reputation influences weight. If an input comes from a rock-solid source, it naturally carries more gravity. It's not just another drop in the bucket. Second, validation strengthens trust. The system doesn't just blindly nod, it actively cross-checks and reinforces the data. Third, historical reliability compounds over time. Think of it like building a good credit score. Trust is earned historically, and the system tracks that. And fourth, and honestly this is the brilliant part, uncertain signals remain visible but provisional. It doesn't just delete what it's unsure about, which would create huge blind spots. It keeps it, but basically sticks a giant question mark on it. It turns a boring, flat spreadsheet into a living, multidimensional model of credibility. Part 4. AI's real-world reasoning. So, why does this abstract data architecture matter to you and me? Let's bring this right back to the real world. Look, for years, the tech world has been completely obsessed with just hoarding more data, building taller and wider piles of information. We constantly hear, oh, our new model has trillions of parameters. But honestly, a taller pile of flat, context-free data doesn't fix the flaw. It probably magnifies it. But structured credibility creates a data set that actually expresses degrees of confidence. It knows exactly what it knows for sure, and crucially, it knows what it's still fuzzy on. The gap between a system that thinks it knows everything equally and one that actually understands its own limits, it's absolutely staggering.
And that exact nuance is what future AI desperately needs to be safe and effective. It's not just about having information. Raw info is everywhere, right? What AI actually needs is to know how much trust different pieces of information deserve. Imagine an AI looking at two totally different medical studies or two conflicting financial reports for a huge investment. It has to be able to evaluate them and say, okay, I trust this one more because of its historical track record and independent validation. If it can't do that, it's literally just guessing at scale.
That structural nuance changes everything. It changes how these intelligent systems learn new concepts from scratch. It shifts how they reason through incredibly complex, multi-layered problems. And ultimately, it completely transforms how they make decisions. Guys, this isn't just some minor software patch happening on a distant server in the cloud. By building trust straight into the data's foundation, we are looking at a total revolution in the safety, reliability, and sheer capability of the high-stakes decisions AI will inevitably make on our behalf. Which leads us to this final thought. Tomorrow, when an AI is deeply embedded in your life, when it makes a critical call about your health or your money or your personal security, will it just know the data or will it know who to trust? Take a second to think about the massive stakes of that difference. Thanks so much for joining me for this explainer.